Alright, so now we're going to talk about how to solve quadratics by factoring when that leading coefficient, that number in front of the x squared, is not 1. And I'm just going to be honest with you, these are significantly more difficult. They add another step, and then they essentially turn into a problem very similar to solving quadratics by factoring when the leading coefficient is 1. But generally, they tend to be larger numbers, and they're just kind of harder to find the factor pairs that multiply to make a certain number, that add to make a certain number. So, okay, so what we're going to do is we're still doing the same thing. We're still looking for this this to get I'm assuming you've watched my video on how to do this when the leading coefficient is 1. But basically, in that video, we talked about how when you factor, you're basically taking this expression and you're breaking it down into two factors. Okay, I know right now that these two factors are going to have to be 2x, and then something here, and then x and something here. And the reason I know that is because this first term is 2x squared. The only way that you can get 2x squared, assuming that we're dealing with whole numbers down here, no like fractions or decimals or anything. The only way you can get 2x squared here is if you do 2x times x. That would give you 2x squared. Okay? Now, the tough thing is that we can't just look for numbers that multiply to make 18 that add to make 15. By the way, there's not a pair of numbers that do that. The problem is that there's a 2 here. The way that the problems worked before was that when we took this and multiplied it by this, and when we took this and multiplied it by this, they just added to that middle number. But the problem here is that there's a 2 here. So when you do 2 times whatever number goes here, it's going to throw this off. And so this 15 is going to be weird. The only thing that I can guarantee you on this one is that these last two numbers have to multiply to make 18. That it's going to have to still work that way. This is the only time when you take this number times this number that you get two numbers multiplying each other, right? 2x times x, you have variables. 2x times this number, you have variables. If you take this number times x, you have variables. But when you take this number times this number, it's 18. So if you want, you can try guess and check here by writing factors of 18. You could do 1 and 18, 2 and 9, 3 and 6. You can mix them up in there until you find a combination that works. You would have to multiply this out. You'd have to FOIL it. Some people would say FOIL, if you're familiar with that term. But I'm going to show you what I feel like is a slightly easier way than guess and check, because guess and check's nice, but sometimes it takes a ton of time. And why guess and check if you can not guess and check? So what we're going to do here is we're going to multiply the back term here by the leading coefficient. And so what we're going to do is we're going to have we're just going to have x squared, and then we're going to do plus 15x and act like we just took the 2 there and brought it to the back number. You'll kind of, like, if you look at the way this works after we do it, you'll kind of see why this works. But I want you to imagine factoring this now. This would factor very differently from this. So I did 2 times 18 and I got 36 there. We are now looking for two numbers that multiply to make 36 that add to make 15. So I'm going to move over here a little bit. So the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9. Wow, there are a lot of them. 5 doesn't go into 36. 6 and 6 go into 36. 7, no. 8, no. 9, we've already got. 10, no. 11, no. 12, we've already got. 13, 14, 15, 16, and 17. None of those go into 36. 18, we've already got. 18's halfway there. So once we get halfway there, we're done having to check. We're looking for a pair here, so that multiplies to make 36, that adds to make 15. So that would be not these guys, not these guys. 3 and 12 should work. Positive 3 and positive 12. I think we're good. So that doesn't work, that doesn't work. This works. 4 and 9 makes 13. 6 and 6 makes 12. So okay, cool. So we got our we got our pair. Now, here's what's interesting. What we're going to do is we're going to actually come back to our original, and we're just going to break up the 15 into 3x and 12x. And this is going to work by what's called grouping. Okay? So this is called factoring by grouping. So I'm going to ignore this for just a minute. I know that that's my ultimate goal, but what I'm going to do is I'm going to take this and bring it down. And so what I've got is 2x squared plus 12x plus 3x plus 18. And now what I want you to do is I want you to kind of think about these two terms grouped together and these two terms grouped together. And I want you to actually factor or divide out the largest possible thing you can divide out of this blue set and this blue set. Well, let's not do them both blue. Let's do one red. Okay, so if you factor out on the blue set here, when I factor out what's the largest thing I could factor out? So I can definitely get a 2. There's also, notice how there's an x in both parts, so you can actually divide by 2x here. When you divide by 2x, think about this. So if you have 2x squared and you take out, if you divide by 2x, what would be left there? I'm going to say there would be an x left. And if you don't believe me, do 2x times x. You'll get 2x squared. Okay, what would be left if we divided 12x by 2x? So I'm going to pull that 2x out of both terms. That would be plus 6. Okay, that's the blue part right there. What about this red part now? I'm going to say the biggest thing we can pull out of 3x and 18, the biggest thing that goes into both of them is just 3. So when we do that, what's left? If we pull 3 out of 3x, so if you divide 3x by 3, you're just left with x. And then if we take 18 and divide by 3, we're left with 6 here. So this is, not blue, this is the red part right here. So what we've done now is we've broken down the original 2x squared plus 15x plus 18 into 2x times x plus 6 plus 3 times x plus 6. And now I want to show you this incredibly amazing trick called grouping. And in order to do that, I need you to bear with me here for a second. So I need you to, if you're not focused and paying 100% attention, I need you to focus and pay 100% attention, because what I'm about to say is really helpful. And a lot of people don't really understand why this works, and it's really helpful to understand this. Okay, so I have a question for you. If I have, and this is completely unrelated to this stuff, but it will come back in just a minute, okay? So if I had, I'm going to use green here. Okay, so if I had 5x and 4x, and I added them together, how many x's would I have? Well, all of you say, well, that's easy. That's 9x. Okay? And I say, cool. That makes sense. If I have 3, let's do purple triangles, and I add 5 purple triangles, how many purple triangles do I have? I have 8 purple triangles. And I think people feel pretty good about this, right? But what gets weird is when we talk about how are you getting 9 and 8? It's so easy to you don't even think about it. But the reason that you're getting 9 is you're doing 5 and 4. You're adding 5 and 4. The reason that you're getting 8 here is because you're adding 3 and 5. So really the answer to this question of what's 5x plus 4x, I'm going to have you rethink this. I want you to think about this more abstractly. I want you to think of 5x plus 4x at the answer being 5 plus 4 x's. I know it's the exact same thing, but when you think about it this way, it's going to make doing what we're about to do much easier. I want you to think of the same way. If I have 3 purple triangles plus 5 purple triangles, what do I really have? I have 3 plus 5 purple triangles. Okay, which is still 8 triangles. This is still 9 x's, because, 5 plus 4 is 9, and 3 plus 5 is 8. But what's important here is that you understand this idea of when you have a similar or a like term, you can actually take this number and say that you have that many of that little term. Okay, it's easy to see when it's just a purple triangle or a green x. It's hard to see when that thing is x plus 6. So what I want you to do is imagine with me for a second, abstract with me here. What if I got to grab a new color here. Let's do like teal, okay? So what if I had 4 teal box plus 3s, and I want to add 2 teal box plus 3s. How many, this is going to sound weird, how many teal box plus 3s do I have? If I have 4 here and then 2 here, I'm going to say that technically I have 4 plus 2 teal box plus 3s. I'm running out of room here. Right? Which is really just saying that we have 6 teal box plus 3s. But I need you to understand that abstract idea there. That we're taking this number of that plus this number of that, and we're just saying that we have 4 plus 2 of that, the teal box plus 3s. Okay, let's take that idea and apply that now to this situation. So essentially what I'm saying here is that the x plus 6 is kind of like our purple triangle. So if I have 2x purple triangles and 3 purple triangles, how many purple triangles do I have? I really have 2x plus 3 purple triangles. What is my purple triangle? It's the x plus 6. So if I have 2x purple triangles and I add 3 more purple triangles, I have 2x plus 3 purple triangles, where the purple triangle, I'm doing air quotes here, is the x plus 6 part. Okay? All right. So I got to erase some things because these notes are going to look incredibly confusing later. So we'll erase the purple triangle, but I hope that helps as you watch that. Okay? Now, check this out. Look at this. We have factored the 2x squared plus 15x plus 18 into 2x plus 3 times x plus 6. That's what we knew. We knew we were trying for something here. We just didn't know what it was going to be, right? We knew it was going to be 2x plus something and x plus something. We just didn't know what the somethings were going to be here. Now we know that the something here was plus 3 and the something here was plus 6. Okay? All right, so let's set this equal to 0. Not in orange, in white. So that's equal to 0. I forgot to write this was equal to 0 all the way along, just like a lot of my students do. All right. So now we're here. We got 2x plus 3 times x plus 6 is equal to 0. And again, we're going to apply the exact same rule that we did for solving by factoring before. So I'm not sure which of these two terms is equal to 0. And by the way, if you didn't watch how to solve by factoring with the leading coefficient equal to 1, you really should, because many of the comments I'm making now are related to that video. But basically what we're saying is if we have something times something is equal to 0, I'm not sure which thing is equal to 0, so I'm just going to give each thing a term equaling 0. So 2x plus 3 is going to be equal to 0, and x plus 6 is going to be equal to 0. If we solve here, let's subtract 3 from both sides. I'll do the first one here. So 2x is going to be equal to negative 3. If you divide by 2, you're going to get x is equal to negative 3 halves. That's one of our solutions, supposedly. And on the other one, if we solve for x, we can just subtract 6 from both sides. We'll end with x is equal to negative 6. Okay, so that's our second solution. What I want to do here is I want to go back and check these. So we're going to check our solutions. So the original function was 2x squared plus 15x plus 18 is equal to 0. And what we're going to do is, supposedly, this will work when x is equal to, let's just get this first awful one out of the way. So let's do, we'll do a green here. Let's do it when x is equal to negative 3 halves. Okay, so what I'm going to do is I'm just going to rewrite this now. And whenever I see an x, I'm just going to put in negative 3 halves there. So 2 times x squared plus 15 times x plus 18 is equal to 0. I'm not saying it's equal to 0. I'm checking to make sure it's equal to 0. So I'm just going to put that little question mark above the equal sign. Okay, 2 times... negative 3 halves squared is going to be 9 fourths. So if you do negative 3 halves times negative 3 halves, that gives you 9 fourths. This is going to be plus 15 times negative 3 halves. This is going to be minus 45 over 2. The 45 comes from doing 15 times negative 3. So I get negative 45, and then I just leave the 2 there. Then I'm going to add 18 here, and supposedly all of this is equal to 0, but I'm not quite sure yet. All right, so this is going to be 18 fourths minus 45 over 2 plus 18 is supposedly equal to 0. And what I was hoping to be a rather simple solution turned into some serious fractions. Hey, let's reduce 18 fourths and get it so that it has the same denominator as this. So we can divide the top and bottom by 2 here. So you get 9 over 2 minus 45 over 2 plus 18 is supposedly equal to 0. And if you do 9 over 2 and you subtract 45 over 2, then you really have negative 36 over 2 plus 18 is equal to 0. And negative 36 over 2 is actually negative 18. So is negative 18 plus 18 actually equal to 0? It is. It works. Cool. All right, so negative 3 halves, which was one of our solutions, actually works. Let's try our other solution. So, gosh, what was our other solution? Negative 6, I think. Yeah, negative 6. Okay, so we'll check. We'll try when x is supposedly equal to negative 6. What color should we use? Let's use yellow. Negative 6. So, all right, let's do it. So apparently 2 times x squared. So x here, instead of putting x, I'm going to put in negative 6 squared plus 15 times negative 6 plus 18 is supposedly equal to 0. Let's put a question mark there because I'm not sure if it actually is. All right, so this is going to be 2 times negative 6 squared is going to be 36, positive 36. Be careful there. It's negative 6 times negative 6. It's not negative 6 times 6. That would give you negative 36. Okay, plus 15 times negative 6, so that's going to be minus 90. And then plus 18 is supposedly 0. 2 times 36 is 72 minus 90 plus 18 is supposedly 0. 72 minus 90, look at that, is minus 18. So that also works. So, my goodness, after all of that is said and done, our final solution, so solving by factoring, our answer here will be that x is equal to negative 6 and negative 3 halves. We'll do that with the little curly brackets. So those are the only 2 solutions in the entire world that if you plug them back in to the original, they actually make it equal 0. Everything else would not work. All right, let's try another one here. So 2x squared minus 2x minus 12 is equal to 0. So again, what we're going to do is we're going to take that first leading coefficient and multiply it by the last number there. And so essentially what we're trying to do is think, all right, if we had x squared minus 2x minus 24 is equal to 0, what could we do? What factors could we find that multiply to make negative 24 that add to make negative 2? And again, since this is a negative here, we're going to have a positive and a negative number. And the question is, we're looking for two numbers that multiply to 24 that are apart from each other by 2. So let's write the factors of 24. So that's 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 is not a factor, 6 we already got, 7 is not a factor, 8 we already have, 9, 10, and 11 are not factors, 12 is a factor. That's it. Those are all the factors that go into 24. So we're looking for a pair here that's separated by 2. So 4 and 6 should work here. And what we're going to do is we're going to now express the negative 2x as a combo of 4x and 6x. Now, again, remember, one of these needs to be negative. So if we're going to end up with negative 2, I'm going to say that we need that. We're going to need that 6 to be negative. So we're going to say 4 and negative 6. Those are how we're going to break that down. So let's do that. So we'll do 2x squared plus 4x minus 6x minus 12. So the only thing I've done here is written negative 2x as 4x minus 6x. We're going to do the exact same thing we did last time. We're going to group this first couple terms. We're going to group these two terms here. Okay. So when we group the yellow terms here, what is the biggest thing we could pull out or divide by for both of them? I'm going to say we could divide by 2 and then x. So 2x we can pull out of those first couple terms. What would be left if you take 2x squared and you divide by 2x? You would have an x left in there. If you took 4x and divided by 2x, you would be left with plus 2. And if you're not sure, just take this, take what you got, multiply it, and see if you end up with 2x squared plus 4x. That's the beautiful thing about algebra. You can a lot of times you can check your answer and be 100% certain that you're right. Okay. I'm not going to do that because I know that's right. And then for the teal, for this one, we've got negative 6x minus 12. And so what we're going to do is we're going to pull out, so we're going to have minus. Now be really careful here. I'm actually going to pull out a negative 6. So if I take negative 6x minus 12 and divide each thing by negative 6, what would actually be left? It would be x plus 2. Okay? Because negative 12 divided by negative 6 is positive 2. So this is going to be x plus 2. There. All right. At this point, what we're going to do is we're going to use that same idea that we had before. So if I have 2x red boxes and I take away 6 red boxes, how many red boxes do I have? I really have whatever 2x minus 6 is of them. So we're going to use that idea again. And the red box in this case, I know it's a little abstract, but the red box is the x plus 2 in this case. So what we're saying here is that we really have 2x minus 6 red boxes where x plus 2 is our red boxes. So that's equal to 0, that's equal to 0, that's equal to 0. I always forget to put the plus 0. Okay. From here, we're going to give each factor a chance to be equal to 0. So 2x minus 6 is equal to 0. X plus 2 is equal to 0. And we'll just solve these out. So you can add 6 to both sides here. You'll get 2x is equal to 6. Divide by 2, you'll get x is 3. And on this one, subtract 2 on both sides, you'll get x is equal to negative 2. So our answer here is that x is equal to -2 and 3. And trust me, I checked. They work. But you could check them if you wanted to. All right, let's do another example. All right, 12x squared minus 18x plus 6. So I'm going to take the 12 and the 6 and multiply that out. And so I'm going to drop the 12 on the front and say this is what's going to be helpful is to do x squared minus 18x plus 12 times 6 is 72. And so now I'm looking for, I guess we don't really need the equal 0 there because we're just trying to break this down. I'm looking for factors of 72. So this is a little, this is going to be a little tough. 1 and 72, 2 and 36, 3. Does 3 go into 72? It does. 3 and 24, 4 and 18. 5, no. 6 and 12. 7, no. 8 and 9. 9, I already got 9. 10, no. 11, no. 12, I already got 12. 13, no. 14, no. 15, nope. 16. 16 going in? No, 16 doesn't go into 72. 17, 18. All right. There may be more factors. I'm going to stop there just from a strategic standpoint because I think I've got most of them. I might be missing like one or two pairs. But I'm going to roll with this. And I'm looking for, okay, so I need two numbers that multiply to make 72 that add to make -18. And I know that if they add to make -18 here, that means that they're both going to have to be negative. So that means essentially that I'm looking for two numbers that multiply to make 72 that add to make 18. I know it's -18, but they're both negative, so whatever. I could just go in, if I really wanted to, I could throw negatives in on all these. But we'll just remember here that all these have to be negative. Okay, so which pair here would add to 18? So that's 73, 38, 27, 22, 18, 17. Bam. All right, so the 612 is what we want. So what we're going to do is we're going to break down this 18 into 6 and 12. So 12x squared minus 6x minus 12x plus 6. So all we've done is break down the -18 into -6, -12, because that was our pair over here. All right, so let's group. We'll do the red here, and then the green here. Group those up. So the red one, what's the largest thing we could divide both of those red terms by? Could pull out 6. And we can pull out x. So let's say that this is 6x. You would be left with 2x minus, if you have -6x and you divide by 6x, what would you have left? You would just have 1. And again, if you're not confident that you did it right, multiply these out. If you did, you'd get 12x squared minus 6x, which is exactly what we started with out there. So we're good. Okay. All right, so we're there, and now what's the largest thing we could pull out of these two? So we could pull out 6. I think that's about it. So I'm going to actually pull out a -6. So I'm going to do -6. I'm going to keep the sign here. So if I pull out a -6 from -12x, so think about it, -12x divided by -6, that would be 2x. And then if I do 6 divided by -6, that would give me -1, so -1. And by the way, hint, hint, as if you haven't noticed this already, ideally this term right here would be the same as this term. Otherwise, we wouldn't be able to group them and combine them like that. So typically when I do this, I'm looking for whatever I get in here to match whatever I have in here, so which it does in our case. Okay, so from here, if I have 6x 2x minus 1s, and I take away 6 2x minus 1s, how many 2x minus 1s do I have? I really have 6x minus 6 of them. So we'll give each term a turn equaling 0. So on this one, we can add 6 to both sides. We'll get 6x is equal to 6. So divide by 6, you'll get x is 1. And on this one, if 2x minus 1 is 0, you can add 1 to both sides. So you get 2x is equal to 1, which means if you divide by 2, you'll get x is equal to 1/2. So x is equal to 1/2, comma 1.